All right, this is Mr. Warwick, and I'm going to go through some of the stuff on the review for you. Fortunately or unfortunately, it's on Delta Math, so I'm just going to kind of look through here, talk about a few different problem types. When I'm looking at this, this is the one at the start. So this is the congruence versus similarity. I had these, I kind of added them in reverse order of what was on the test. So the stuff at the top is what's actually going to be at the end of the test. The stuff at the bottom is actually going to be what's at the start of the test. So on the congruence versus similarity, you should be able to tell, are they the same shape or are they not the same shape? These two, I know, Sophie, that's my dog. These two are not the same size, but they are the same shape. So I would say they are not congruent because rigid motions can't make them work together, but they are similar because if we throw in the dilations right here, this word, dilations, changing the size, it'll work. The scale factor is going to be the toughest part. So what I try to do is look at something that I know is relative. I know that TU is going to be the side that matches up to ML. This goes down 1 and over 1, 2, where I'm looking with my mouse, okay? Down 1 over 1, 2. This one goes up 1, 2, and over 1, 2, 3, 4. That's twice as many. And I'll look and see which one is going to which one. It says this one's going to this one. So I'm not multiplying by 2 to get this shape to this shape. I'm dividing by 2. But scale factors are always multiplying. So I'm going to multiply by 1/2. This one up here is half the size. I multiply by 1/2 to get there. Okay, I do want to point out on these, if I can find one, new problem. If you do get one that looks like this, these are the same size. So they're going to be congruent. So you tell it, yes, these are congruent because you can use the rigid motions to make them equal to one another. Because of a quirk in this program, you say they're also similar. And if they are congruent, the scale factor is just 1. If we multiply all the length of the sides by 1, they're going to be exactly the same. We submit, and this should be fine. I made it to where the scale factor of 1 stuff is not going to show up on the test. So you should be safe there if that was your only hang-up. Dilations on the coordinate plane, this is going to be there. You shouldn't need a calculator for this, but there is a calculator up here if you're having trouble multiplying by the fractions. If you do have a fraction here, it's multiply by the top, divide by the bottom, and all of these things are going to come out even when you do it, okay? This is -4, 6. If I multiply that by 3/2, 3/2 of -4 is going to be -6. 3/2 of 6 is going to be 8, so I'm going to be out here. I get bigger. 3/2 of 4 is 6, so I'm over here. And then I'll click there again. 3/2 of -4 going to be -6. And then I'm up here. The only thing I did for this on the test is try to limit it to like triangles and quadrilaterals so that you don't, oops. What did I do wrong? Oh, I was just off by a little bit. I didn't go all the way up. Should have gone up to 9. Go figure. Missed it by just a little bit, okay? Just trying to work too quick, got sloppy. That's my mistake, okay? Happens to the best of us. Here's the thing that you should mainly focus on. Whenever your fraction is less than 1, you know you're going to get smaller. Whenever your fraction is bigger than 1 or you have a whole number, you're going to be getting bigger. And I tried to limit this one to only 3 and 4-sided figures so that you wouldn't have to do a ton of multiplication trying to get 5 points or anything out like that. Okay? Let's see. The next one, identifying the transformations. Figure U is a result of a transformation to T. Which one would accomplish this? 3 down would only go 1, 2, 3. Nope, that's what I need. I need 3 down. The rotation doesn't make sense. 3 units up would do it the other way. 90 degrees clockwise wouldn't make it the same thing. So really, you just need to make sure figure U is the result of a transformation to T. So I'm taking T to U. It needs to go down. Okay. Figure Y, that's a translation to the left. Is there going to be one here? Yeah. If you get one like this where it says rotations, and yeah, this one's got the 2 different directions on it. Remember, the clock is still on the wall. Clockwise is top to the right. Counterclockwise is top to the left. So I want the top of this figure out here to go to the left. So this is counterclockwise rotation. I submit, and it does it. Oh, I didn't read the direction. U was supposed to go to V. That one's clockwise. Okay. I'm just having all kinds of fun with this today. Okay, the next one down, translation of a point. Right 4 units is going to add 4 to the x value. That's going to make it 8. From a -7, up 5 units is going to add 5. That's going to make that a -2. And there we go. This will be a test, so it won't immediately tell you if you got the problem right and go through the whole explanation, or it shouldn't. Translate the figure graphically. This one says go 2 units to the right and 7 down. So 1, 2, 1, 2, 3, 4, 5, 6, 7. There's my new one. 2 units to the right, 1, 2, and down 1, 2, 3, 4, 5, 6, 7. There's that point. And then 1, 2, and 1, 2, 3, 4, 5, 6, 7. There's my new triangle. Hooray. I have done the transformation, and it likes it. Okay. Again, I tried to limit the shapes on that one so you're not having to translate some 8-sided figure or anything like that. Single rotation or reflection. Again, same kind of thing. We're just identifying how do we get from A to B. This time, they're helping me out a little bit. Getting from A to B, a reflection wouldn't do it. This does need to be a rotation. We need to turn this. We're going against how the numbers go on the clock, so that's counterclockwise. Remember, if they do have both of these on here, counterclockwise 270, every 90 degrees goes through one quadrant. So 270 would be 1, 2, 3. It would put it over here. So 271 direction is the same as 90 the other. Okay, I submit it. It does the nice little rotation. We see it there. And you see this one is centered on the origin. All the questions should be that way. But the one on the performance task, the practice performance task today, was not centered about the origin. So you do have to be careful on that. Okay. Reflecting the figure over a line. This one actually gives us other lines than the x-axis, y-axis. But really all you have to do is, this one is 1 away from the line, so I go 1 away in the other direction. This one is 1, 2 away from the line, so I go 1, 2 in the other direction. This one is 1, 2, 3, 4, 5, so I go 1, 2, 3, 4, 5. There that one is. And then this one is 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. I don't even bother with the numbers over here. I don't try to confuse myself. I only look at the line and how far it is from the line. I'm going to submit my answer. And what do you know? It likes my answer. This is another one that I really did try to limit the size of the figures. So you're not trying to drag across like 8 irregular shaped points just to make it a little bit quicker for you when you work the test. You should still know how to do it. The rotational symmetry, we say if it does or does not have rotational symmetry. At first glance, this one does not look like it does because of the wonky shapes, but this wonky shape is going to match up to this one and this one. So this one is going to have rotational symmetry. And remember, it's 360 degrees to go all the way around. So this one's got 3 spaces where it's going to match up. So 360 divided by 3 there is going to give me 120 degrees of rotation. I don't know if you'll be able to try on the test, but it looks like here that 120 is going to be where I need, and I submit my answer and go. Remember, it's 360 divided by the number. This is probably going to be the only thing you would need the calculator on. And again, right up here in the corner of Delta Math is a calculator. I'm going to be monitoring your traffic. Don't go jumping around on Desmos. Okay, and then lines of symmetry. The last thing here, do I have some lines of symmetry in this shape? It looks like I have one that's going to go right here. Again, this is not something that you have to be perfect on. And that means I probably have one here as well. And this repeated pattern is going to go for over here. Again, I tried to limit the number of possible lines that you were going to have. I didn't put in like the 10 and 20 sided figures like we had some practice problems there. And the test, just like the practice ones, it's not going to expect you to do a ton. These don't even all match up. So this one probably only has the single line of symmetry right there, and just call it a winner. Okay. Any number of these, this one appears to be an isosceles triangle, only going to have one. Okay, so that's what we're looking at. If you have any other questions, just make sure come in tutorials before class, flex, something like that. Try to get some of this stuff knocked out. Try to ask anything that you're going to have questions on, and hopefully this gets you through the test tomorrow. Have a good rest of your evening, and good luck on the test.